So today we'll be continuing looking at how to solve Diophantine equations, and today we're going to look at another factorization technique. And unlike last time, which was a technique that may have been new to most people, some people, however, this one I think all of you should know, which is the difference of squares. So, um, you'll be wondering, like, why are we learning this factorization technique when it's so simple? Well, this video is all about just like last, just like the last video. Um, it's all about observing where you can, um, where you can factorize this. So if you watch the last video, if we have the form like xy plus ax plus by equals an integer, or like plus an integer equals an integer or whatever, then we can always factorize it into the form, oh no, not like this. This a equals an integer to test all the cases. So yeah, if you didn't watch this video, then watch the last video, then go watch it because you'll need it for this video. But yeah, it's all about observing where you can do this technique. So you must be able to observe where you can do difference of squares, and it's not just like single variable squares. It's like expression squared. So yeah, it's all about observing. But first, we're gonna do a simple one, a simple question, which says x squared minus y squared equals -3, where x and y are integers. Then we can factorize this. So I told you that in the last video that when you solve Diophantine equations, the best form you can get is having an integer and then saying that an integer expression times an integer expression equals that integer. And then you can just test the cases. This could be -3, this could be 1, this can be 1 and -3, and then this can be -1 and 3, and then this can be 3 and -1. And then we can just, and then for each case, for example, for case number 1, if we say this is case number 1, then for case number 1, x plus y equals -3, x minus y is equal to 1. And if we simultaneously solve them, then xy is equal to -1 and what is it? -1 and -2 or something, yeah. So, but this is not the only answer. You have to do this for every single case. But I'm not gonna do that now because it's pretty. I mean, you guys will know how to do this simultaneous equation thing. But anyways, yeah, this is how you do it. And this was a really simple case, and we're gonna try a more hidden problem this time, if that's how you call it. So this time, okay, we can kind of see a difference of squares here. But we have this annoying 2x in the middle that we don't know how to deal with. But we're going to just try to make it into the form of an expression squared minus a square. So we already have a minus squared expression. What if we try to add some integers to this side and this side so that this expression becomes a square of an expression? And we know that if we add 1, then this is equal to x plus 1 squared. And if we add 1, then this will just stay an integer because this is an integer, it's a constant. So it doesn't really matter if we just add an integer. This will just stay an integer, and this will become a nicer expression, which is the square of an expression minus the square of an expression. So like whenever you're trying to like add or multiply whatever to both sides, you have to see like if how better one side becomes, how more elegant, how simpler or nicer a side becomes, kind of overcomes whatever side effect it has on the other side of the equation. So you have to always evaluate if that happens. But in this case, this has literally no difference. It just stays a constant integer. And then we'll get, if we add 1, yeah, I'll just have to do it so that you guys can see what's happening. Minus, put that in black. y squared equals 2, and then this is just x plus 1 squared, x plus 1 squared, 2 plus 1, x plus 1 squared minus y squared equals 3, and then so x plus 1 plus y, if we do the factorization, equals 3. And then, yeah, we just test 3, 1, when this is 3 and this is 1, and then when this is 1 and this is 3, -1, and so on. Yeah, so, yeah, there's literally no space. But, okay, I'll just try to write it all in so that you guys can confirm that, we have all the cases. Yeah, so these are the only cases here. And, yeah, just like before, for example, for the first case, we'll just simultaneously solve like x plus y equals like this, and then you'll realize that these, when you do difference of squares, the way of solving these simultaneous equations is actually pretty simple, because it's like an expression plus an expression, and then that expression minus the expression. So if you add the two, then you can solve for this, and if you minus the two, you can solve for this. It's pretty simple, which is pretty nice. And that's why if you see difference of squares, I get pretty excited, because it just becomes so much easier to solve. So that's not the point here, but how we manipulated this to get the square. And whenever you look at a solution, you should never just accept it. You have to know you have to know the true motive behind why that person may have used that technique. So why do we add 1? Well, we observed that it's kind of in the form of a square minus a square. So if we put this in the form of a square of an expression, then we'll get this. And the reason why I thought that this can become a square of an integer is because in general, x squared plus 2ax plus a squared is equal to x plus a squared for an integer a. So in this case, we only have this part. So x squared plus 2 times an integer times x. And in this case, a is equal to 1. So if we add a squared, which is 1, to both sides, then we'll get a square expression for here. So that means, just like for the technique we did with this, remember this? Yeah, I wrote it before. If whenever we see this expression, this form, then we can always factorize it into this thing by adding an integer on both sides or something, like similar to this. We can, if we see this form, we just find what a is supposed to be, and then add the integer a squared to both sides to make this a square expression. So like in general, yeah, I think doing these problems is enough to show the technique. But actually, wait, where should I write this? Yeah, I'll write it on top here. So this means that, I'll put it in blue because it's more important. So that means if we see x squared plus 2a minus y squared plus 2y, not 2y, minus 2by equals an integer, well, we can add a squared. We can add a squared to here. Okay, so we can add a squared on both sides to make this x plus a squared, and then we can add, and then not only just x but like y. In this case, we didn't have the term y in here, but now we have the term y, but it's exactly the same. If we minus y squared, actually, if we minus y squared, then this will become minus y plus b squared. So this entire thing will become right at the bottom. This entire thing will become x plus a squared minus y plus b squared. And then we can factorize that. But the important thing is, will this side be an integer? Of course, because if we add the a squared and minus the, not y squared, sorry, not y squared. Let me rewrite that. minus b squared. So it'll be plus a squared minus b squared, which will definitely be an integer because a and b are integers. So this entire thing will be an integer. So we have difference of squares equals an integer. And we know x plus a and y plus b will be integers because x and y are integers, if that is given. So yeah, I don't think it's necessary to do a problem with the y term. I think it's enough to observe like how to add stuff. And so if you see this form, so for example, like if it's like x squared plus 4x minus y squared minus 6y equals 1, then if you add 4, because a is 2 in this case, and if you add 9, then you will get a difference of squares. Yeah, so you can try that on your own. That is how it works. Yeah, so a relatively simple technique, but a bit more complicated to observe, like how to use this appropriately. So yeah, and not only factorization, not only for not only for number theory, but also for other like algebra and like other techniques, being able to see if it's a difference of squares, making it into a difference of squares is a very important technique that you'll have to know. So yeah, that is the end of this video and hope to see you in my other videos.